In this video we're going to be looking at mutually exclusive events, we're going to be looking at exhaustive events, and we're going to be looking at independent events. And it is very important that we understand the differences in these, and when you see the words mutually exclusive, exhaustive or independent events, then you know what that actually means mathematically and then how you can apply that to the question. First of all, we have got mutually exclusive events. Now, mutually exclusive events are events which are able to happen, but they cannot happen at the same time. So for example, if you toss a coin, the event getting a head and the event getting a tail, you can toss a coin and get a head, you can toss a coin and get a tail, so they can happen, but you cannot toss a coin and at the same time get a head and a tail. So getting a head and getting a tail are what's called mutually exclusive events. So the probability, when you have mutually exclusive events, your probability of getting A and B is equal to 0. So that means your probability of A or B is equal to the probability of A minus the probability of B. Remember your formula, it would have been then minus your probability of A and B. But if that's thing 0, you're just taking away 0. So really, that's why you have this formula. So if two events are mutually exclusive, they cannot happen at the same time, then it means the probability of A or B is equal to the probability of A plus the probability of B. And this can be extended to any number of results. So here, if you've got n exclusive events or mutually exclusive events, the probability of A1 or A2 or A3 or A4 all the way up to AN is the probability of A1 plus probability of A2 plus probability of A3 plus probability of A4 plus all the way up to probability of AN. This example says, a card is drawn at random from an ordinary pack of 52 cards. What is the probability the card is a club or a diamond? Now, being a club or a diamond, you can be a club, you can be a diamond, but you cannot be a club and a diamond. So probability of a club or diamond, C or D, is equal to just the probability of a club plus the probability of a diamond. Now, you can make this very easy by using 1/4 if a pack is a club, 1/4 if a pack is a diamond. Add a quarter and a quarter, you will get 2/4, which is just a half. Okay, part B, a wee bit different for part B. Part B, first of all, can we say, it asks you to find the probability of a club or a king. So just say club and king are not mutually exclusive. Okay, so you've got to be very careful. Not everything is going to be mutually exclusive, and a club and king are not. And the reason for that is because of one single card, the king of clubs. So it is a king and it is a club at the same time. So that means we're looking for a club or a king. Club or a king, which equals the probability of a club plus the probability of a king minus the probability of a club and a king. Now, if we use 52 as our denominator, we have 13 clubs out of 52. That's obviously the same as a quarter, but if you use it as this, it will make life easier. We have 4 out of 52 kings, and we have only one card, which is both a club and a king. And when you do that, you will get 16 out of 52, which cancels down to be 4 over 13, and that is it. Next up, we've got exhaustive events. So it says here, if two events A and B are such that between them they make up the whole possibility space, or they cover all the possible outcomes, then A and B are said to be exhaustive events. So i.e. A, if you pick A or B, it's going to be 1. So the probability of A or B is going to be 1. So for example, if you roll the dice, the probability of you getting an odd or an even is going to be 1, because odd or even, between them, they cover all the possible outcomes, and that is it. Next up, we have independent events. So a couple of rules for independent events. If either of the events A and B can occur without being affected by the other, then the events are independent. If A and B are independent, then you can say that the probability of A and B is equal to the probability of A times the probability of B. We will see a wee bit later on about our conditional probabilities as well. There's a couple of other rules for this, but that's one event. One way of showing it, two things are independent. So if you're A and B, probability of A and B is equal to the probability of A times the probability of B. This is known as a multiplication rule, and again, a wee bit later on we'll see how this applies when we look at our tree diagrams. This example says, on a dice, the probability of rolling a number is proportional to the number rolled. So probability of 1 is equal to k, probability of 2 is equal to 2k, etc. A bias coin is tossed where the ratio of heads to tails is 3 to 1. Find the probability of rolling a prime number and tossing a tail. Before we can even think about actually looking at finding probability of rolling a prime number and tossing a tail, we've got to find a whole pile of probabilities here. So we have a bit of work to do here. So first of all, for your dice, we're going to do out our possibility space. You've got your variable x, the probability that x is equal to x, and then we're going to draw out our table. So x, if it's a dice, could be 1, 2, 3, 4, 5, or 6, very clearly. And then it was k, 2k, 3k, 4k, 5k, and 6k. So this is a sum. These are exhaustive events. Everything is coming into play in this question. These are exhaustive events. So if you add up all those k's, you'll have 21k. And the sum of all the events, all the probabilities, adds up to 1, which means your k works out to be 1 over 21. Okay, so that's for your dice. For your coin, and it says the ratio of heads to tails is 3 to 1. So that means the probability of getting a head is 3 out of 4 parts. The probability of getting a tail is 1 out of 4 parts. And we are now ready to start our question. So the question says, find the probability of rolling a prime number and tossing a tail. So you're saying you're getting a prime and a tail. And we're going to list all the ways we can do that. So your prime number, your first prime number is 2. So you can get a 2 and a tail. Or, and if I say the word or, generally I'm adding, I could get a 3 and a tail, and only one more prime number left. It's going to be 5 and 5 and a tail. So 2 and a tail is going to be 2 over 21. The probability of getting a tail is a quarter. So I've said and, so that's 2 and a tail. So when you say and, you multiply. Or I've added, I could get a 3, so 3 over 21 and a tail. So I multiply a quarter. Or, so I've said or, so I add, I could get a 5 and a tail, so I multiply, so that's going to be a quarter. So when you do that, and you can do it all in your calculator, 2 over 21 times 1 quarter, 3 over 21 times 1 quarter, 5 over 21 times 1 quarter, on your calculator will give you 10 over 84, and if you'd hit it into your calculator, it would have given you 5 over 42. It would do the cancelling for you. Just another note, it says here, it can be shown that if A and B are independent, then not A and not B are also independent. Hence for independent events A and B, that means the probability of not A and not B is equal to the probability of not A times not B. This example says, the events A and B are independent such that probability of A is equal to X, probability of B is equal to X plus 0.2, and probability of A and B is equal to 0.15. Find the probability of A union B. So a good place to start is to write down your formula. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. Now what we also know is that the probability, because they're independent, probability of A and B just equals your probability of A times your probability of B. So in this case, and we also know, we're told, the probability of A and B is equal to 0.15, which is equal to then X times X plus 0.2. So we can multiply it out. So you'll have 0.15 is equal to X squared plus 0.2X. Bring everything over to one side, put it equal to 0. You'll have X squared plus 0.2x minus 0.15, and then we can factorize that. That's going to be x plus 0.5 upon x minus 0.3. That's how that will factorize, which gives you x is equal to minus 0.5 or x is equal to 0.3. Now think about what we're talking about x being. X is a probability of A, so it cannot be equal to minus 0.5. So your answer, so this one, just put a wee IMP to show this one is impossible, and you understand that that's impossible. And then, so this one, tick this one, this is right. So what have we got? We have got so far that our probability of A then we've worked out is 0.3. Your probability of B was x plus 0.3, so it's going to be 0.5. And your probability of A intersect B, they tell you in the question, is 0.15. We are good to go. You can just say, therefore, your probability of A union B is equal to your probability of A, 0.3, your probability of B, 0.5, minus your intersection, 0.15. And if you do that, what you will get is 0.65. And that's it. We note here, it says, don't confuse mutually exclusive events and independent events. Mutually exclusive events are events that cannot happen together. Independent events are events that can happen simultaneously or can be seen to happen one after the other. So how I'm going to remember this, you've got your mutually exclusive events. They are A or B. For mutually exclusive events, it is just equal to probability of A plus the probability of B. And what I call this is the OR rule. And for independent events, you've got your probability of A and your probability of B is equal to your probability of A times your probability of B. And this is called the AND rule. So basically, if you say OR, you add. If you say AND, you multiply. Okay, this example says three events A, B, and C. You've A and C are mutually exclusive, A and B are independent. It says probability of A is equal to 2/5, probability of C is equal to 1/3, and the probability of A union B is 5/8. What the question asks you to do is find the probability of A union C and also the probability of B. Okay, there's an awful lot going on there. What I would do in a question like this, I would start by writing down everything we've got. So probability of A is 2/5. Probability of C, we're told, is 1/3. And you're also told that your A union B is equal to 5/8. So we're going to use it to get started. We're going to say that probability of A union B, I'm going to write out the formula for it. It would be probability of A plus the probability of B minus the probability of A intersect B. Now, because we are told that A and B are independent, that's going to be probability of A, probability of B, and A and B are independent, so that means probability of A and B is the same as probability of A times the probability of B. So that's because they are independent. So we can fill in what you know. You're told probability of A and B is 5/8. Probability of A was 2/5. Probability of B, we don't know. So just write it as probability of B. And then probability of A again was 2/5 times your probability of B. Now tidy all of this up. You're going to have 5/8 minus 2/5 is going to be equal to probability of B minus 2/5 of probability of B minus 2/5 of the probability of B. You will have 3/5 times the probability of B. And again, we can tidy all of that up to give you a wee bit of working out. Is going to give you that your probability of B is going to be equal to 3/8. So we've calculated the first bit. We found our probability of B. Next bit asks you to find the probability of A union C. Now it tells you that A and C are mutually exclusive. So that means if they're mutually exclusive, A or C, is just going to be probability of A plus the probability of C. And then that is just going to be 2/5 plus 1/3. And when you work that out, that is going to be 11/15. Okay, this next example says, in a survey of 100 people, 14 said they like cats, and 35 said they like dogs, and 15 said they like both. Represent this on a Venn diagram. Now, this is not a particularly well worded example. It says we've got 100 people, 14 said they like cats. So do not take this down, please. I would have been thinking that meant that the whole 14, this whole circle represents 14. Likewise, it says 35 think they said they like dogs, and 15 said they like both. But if this whole bit was 14, and then that's 15 in here, that means this bit really in here, this part here, really represents -1. So how they've worded it, it's a bit ambiguous. Ambiguous means it could be interpreted a couple of ways. So what they really mean here is 14 like cats only. So it's 14 just for this part here without the overlap. That's 14. 35 like dogs. So 35 like dogs, so that's dogs only. And 15 said they like both. So that's really what you've got. Add those three numbers, take it away from 100, you'll get 36 outside. So that's really what we have. Okay, I'm going to pause the video and then we're going to go down and have a look at the questions on this one. Okay, I've just drawn my Venn diagram again so we can see it. What the question asks you to find is probability of a cat. So probably somebody likes a cat is going to be 14 plus 15 is going to be 29 over 100. Just check you can cancel down. This one you can't. Next one asks you to find the probability of a dog. A dog is going to be 15 plus 35, which is going to be 50 out of 100, which is going to be a half. Next one is a cat and a dog is just 15 out of 100. 15 out of 100 cancels down to be 3 over 20. Next one is not a cat. So not a cat is going to be 35 plus the, I can even do it a better way. We know up here probably if a cat is 29 out of 100. So it's going to be 1 minus 29 out of 100, which is going to be 71 out of 100. Not a dog is also going to be 1 minus a half, which is still going to be a half. Probability of a cat union dog is going to be 14 plus 15 plus 35, which is going to be 64 out of 100, which cancels down to be 16 out of 25. And then not a cat and a dog. So not a cat and a dog is going to be 35. So it's just going to be this bit in here. This bit in here, this 35. So it's going to be 35 out of 100. So it was 35 out of 100, which cancels down to be 7 over 20. Next one is a dog and not, a cat and not a dog is going to just be our 14 out of 100, which cancels down to be 7 out of 50. And we scroll on down here. So onto the trickier ones then, it asks you, for part I, it asks you for the probability someone is not a cat or they're a dog. So it's not a cat or a dog. So not a cat or a dog is going to be, not a cat or a dog is going to be this one here. So not a cat is going to be 35 or the 36. So it's going to be the 71 out of 100. And then we have got a cat or not a dog is going to be the 14 plus the 36, which is going to be 50 out of 100, which is going to be a half. And then not a cat and not a dog. So not a cat and not a dog is just going to be this bit outside. So this 36 here. So if we just put that in, it's going to be 36 out of 100, which again cancels down to be 9 over 25. And the last one is not a cat or not a dog. So let's just work this one out and see. So not a cat or a dog, we're going to work it out the long way. Probably not a cat plus a probability of not a dog minus a probability of not a cat and not a dog. I think we've got these things worked out. So probability of not a cat is 71 out of 100. probability of not a dog was 50 out of 100, and the probability of not a cat and a not a dog was 36 out of 100. So if you do that out, you will get 17 out of 20.